We've got to keep things moving. They're very strict about time here. Now representing Dunedin, Southland and Otago, we have Deep Space Labs, who have developed new multispectral data analysis techniques powered by machine learning and artificial intelligence that will allow for safe, quick and inexpensive science to be conducted across Antarctica and throughout the solar system. Could you please welcome Anton Hughes.
All right. Hello? Hello. I just want to say a quick thank you to Emmeline and Eric for organizing this. This has been a wonderful opportunity. And actually, I'm Adam Campbell from Deep Space Labs. And I want to talk to you today about our proposal for making exploration in hazardous environments safe. And I'm not sure how to change the green button.
Top one.
Top one. Oh, okay, cool. All right, so the problem, which you're all aware of, is that there are large crevasses in the Ross Ice Shelf, and they're often covered with snow bridges, which make them visible to the naked eye and from satellites above. So how do you navigate across these dangerous crevasses safely? The solution that we've developed here at Deep Space Labs involves autonomous hazard detection. So we want to use the problem of detecting crevasses in the Ross Ice Shelf as a way to become a company that specializes in autonomous hazard detection and mapping. So how are we going to do that? Well, we've developed a product roadmap that will help us go from a company starting this Antarctic exploration into a space technology company. And so we've developed lots of different products, and I'm going to spend a little bit of time highlighting some of the, just 3 of these products today. The first product that I'm going to talk about is the Ground Truth. What this does is combines some old reliable technology with the new machine learning algorithms. And so what we're going to do is use ground penetrating radar and apply machine learning algorithms to it to automatically detect crevasses from GPR radargrams. This will be a very quick system that can easily identify crevasses in real time. The second product that I'd like to talk about is our shear zone monitoring product. And the reason we wanted to highlight this one is because it was the most exciting to the people that we talked to, our potential customers. And what this is to develop a behavioral understanding of the Ross Island shear zone while providing safe passage. So what we propose is a balloon that is equipped with multispectral data sources, which include GPS, interferometric reflectometry, and microwave backscatter. And these are both sensitive to snow thicknesses and voids. And these will provide new multispectral ways of detecting crevasses that aren't currently available. And since we're testing this in the Ross Island shear zone, we will be able to detect crevasses with traditional GPR methods, providing a safe, navigable passage through this very dangerous area, which is essentially the gateway to the Ross Ice Shelf from McMurdo and Scott Base. This is the most heavily crevassed area because it's where fast ice meets slow ice, and when you have fast ice coming together with slow ice, you get crevasses. All right, so the next product that I'm going to talk about is our backseat driver. And the reason I wanted to talk to you about this one is because this is the one that has the lowest barrier to entry. We think that this is going to be the new standard for safety in Antarctic research. And so what this does is it takes our Ground Truth product and essentially puts it in the vehicle and says, okay, I've detected a crevasse, and alerts the driver immediately. And so the driver of the vehicle will see that and know that there's a crevasse. And this will be the new standard for how people do it, for how Antarctic researchers do it once this is available. So we have some creative integration, and this is based on trusted technologies with new data sources and applying machine learning to new data sources to really make us a company that can take multispectral data and use that to detect hazards in dangerous environments. So to talk a little bit about some implementation plans, here's just an example for our Ground Truth phase. This is a 6-month implementation plan going from data preparation all the way up to production ready. And we feel that this is somewhat characteristic of some other products that we've developed. We have lots of collaboration with stakeholders. So we've consulted with many experts who've been in Antarctica, based here in New Zealand and in the United States. They work for government agencies and space agencies. And we see potential collaborators and customers with places like Antarctic research programs. For example, the New Zealand, Korea, and Italy have a shared logistics agreement that we think we could use as kind of a foothold getting into this industry. But also NASA and ESA, Planetary Resources. Once we've developed that multispectral technique of this hazard detection, we really think that we have some really cool space technologies that we can exploit. So why us and why now? Well, the technology is capable and mature. The space industry is beginning, and we've developed fast deployable technologies to detect hazards. And this is going to reduce the environmental impact by essentially through this automation process. If you have less time that people are spending in vehicles, it means there's less travel. All right, so just to talk quickly to wrap up with our team, Deep Space Labs is founded by experts in machine learning, Antarctic science, statistics, remote sensing, software development, and artificial intelligence. We are a Dunedin-based Kiwi company, and we're really excited to go forward. So I'll just finish up by thanking you and just let you read this testimonial as we take questions from the panel. Thank you. And I'll invite my co-founders, Anton and Josephine, up here to answer questions as well.
So, you know, it's coming. Can you elaborate more on the use of the space technology? Because it wasn't that much in the presentation. So.
Yeah, we heard a lot of talks today about balloons. Another name for the balloon is the Aerobot, which is the people that we've talked to, one of our favourite products, what we call the tethered balloon or the shear zone monitoring. So this Aerobot or tethered balloon will be fixed with some very sophisticated sensors. And of course, machine learning and AI is very prevalent in space technology. Additionally, another product that we didn't go into detail was what we call the Roomba Mapper, which is an autonomous way of using the ground penetrating radar. So that's based, of course, off the rovers that you see on Mars.
So I have a question. How much do you understand about wind and wind speeds, and how will those balloon-based systems perform in that environment?
Yeah, I think that's a great question. So we imagine that the balloon would be tethered and retractable, not only for wind problems, but also because we do anticipate operating this in the Ross Island shear zone. So there might be logistical reasons for lowering the balloon. We don't want to interfere with air traffic at McMurdo Base or Scott Base. So yes, this will be something that is retractable. And right now the U.S. Antarctic program only recertifies the route through the shear zone every 20 days. So if we could get even a little bit extra on that, we're doing a great job, I think.
Is the microwave backscatter technique, has it been tested at higher altitudes than close to the ground? How high has it been tested at?
That's a good question. Yes, it has been tested above ground at least several meters. But yeah, it's still a technology we want to work with. Yeah.
You have quite a chain of technologies involved here, which is very interesting. If you need to determine a priority, in your opinion, what's the most important one?
Well, I think that the backseat driver and well, everything depends on the ground truth. Being able to automatically detect crevasses with machine learning techniques or CPR. Everything really depends on that. And like I said, I think our backseat driver product has really the lowest barrier to injury. It's just taking that and putting it on a box and putting it in a vehicle, which I think is a very accomplishable goal for our company.
Hi. What proof of concept do you have so far?
Yeah, well, we've started to work with some, we've gathered some ground penetrating radar data that's been that's been collected that is of the right frequency that it will reveal crevasses. So we've talked with some American collaborators who've shared this data with us. And so we're kind of at that level of just gathering the data and cleaning it, and then once we can get there, we can do the kind of machine learning kind of techniques of that, yeah.